So who's this video for? This video is for anyone who wants to learn how to code, and it's also for those who have no choice but to learn how to read and write Perl code because your team or institution or whatever relies on a bunch of legacy Perl code. This is not going to cover absolutely everything. This is just simply enough to find your feet in the language. So Perl is a Swiss Army knife of a programming language. You can use it as anything from a command line tool all the way up to creating modern web applications. There is a large and active community of people creating new modules for Perl all the time and maintaining old ones. And the world is full of legacy Perl code, so you can really get an edge in the job market by knowing your way around a Perl project. Perl 5 or Perl 6. Perl 6 you can think of as a totally different language. It's called Roku now, and so we'll just be looking at Perl 5. Let's head over to VS Code to get started. That's the text editor I'll be using in this course, but others are available, obviously. You just need a text editor you're comfortable with, and the same thing with a terminal. Down here I've got my terminal where I can execute the Perl script, and up here I've got my text editor where I can write the Perl code. Alright, so just before we write any Perl code, we want to make sure we actually have it installed on our system. So most Linux distributions, and especially if you're on OS X, you'll have Perl already installed. Now to test this, you go to your command line and you type Perl, all lowercase, space, and then your argument, -v, and press enter. And I'll just expand that here. That is showing me that I have Perl 5 installed at version 30, and other copyright information. But basically, if it comes up saying something like program not found, then you'll need to install Perl. As we can see here, I've got it already installed. Now, if you do need to install Perl, I'll put the link below. So if you're on a Windows system that might not already come with it, or some Linux distributions, then head over to perl.org, and up in the navbar we've got download, and you basically just follow whichever set of instructions is correct for your operating system, and then you should be good to go. And you head back to the command line and do the Perl-V and test that you've got it installed. There are 4 things you need to know about scripting in Perl, 4 basic things, and they are that a Perl file, Perl script file, will always end in .pl. So if you see a .pl, it's a Perl file. Just like if you see a .py file, it's for Python. And if you've got a .txt file, it's a basic text document. So let's head into VS Code again and create ourselves a Perl script. So to do that, you can, in VS Code, either go up to this add file icon, or in your command line you can go touch. We'll call this hello world, and then .pl. Press enter and we should see it appear up here. Click on that. Even VS Code has recognized that as a Perl script and given us the little camel icon. Second thing you need to know about scripting in Perl is that scripts always start with the following 2 modules, and they are use strict and use warnings. These are known as pragmas. Pragmas affect the code at compile time, not at runtime. And basically, it's just a list of rules that keep your code looking and acting as people would expect it to. Because Perl is incredibly permissive, and by that I mean it will allow you to write really bonkers code that no one will ever be able to understand. So using these 2 pragmas allow us to create more readable, more usable code. Put them into our file. So use is how we use a module. So use strict and use warnings. And there you will see them at the top of most Perl scripts. Number 3. That is commenting. Or rather, I should go to number 4 first. So lines always end with semicolons, just like PHP if you've used that before. And if you see in here, I've already made a mistake. I haven't ended the 2 lines with semicolons. The file will break. It won't be able to compile if you miss these off. Now, number 4 is how to comment. And commenting in Perl is with the hash. And you can do that here. So put a hash in, and then I can write my comment. So this is my first Perl script. There we go. So the final thing we need to do is actually print out hello world. So to do this, we use the print statement with parentheses at the end and making sure we finish every line with a semicolon. We pass it double quotes instead of single quotes, and then type hello world. Cool. Okay, so let's run this from the terminal by typing Perl space hello world.pl. That's given us hello world and then this weird character that we haven't put in there. And what that's telling us is that there was no new line. To demonstrate this, we can copy this line down and save it and run it. And then we can see that hello world isn't put onto a new line despite there being 2 print statements, as there would be if you were using Python. Now to fix this, we simply put a new line character, which is a \n at the end of the string. We'll save that, and I'll clear the terminal, rerun the same command by clicking up and enter, and I can see that there's a nice hello world with no random extra characters there. Okay, so that's the end of this video. In the next one, we'll look at hello world again, but running it in a slightly different way, not from a script, just straight from the command line. It'll be a much shorter video. It won't contain all the waffle I had at the beginning. And thank you for watching. Please let me know if you think this video was great or if it was crap. Like it, dislike it. Feedback would be great. So thank you, and I'll see you in the next one. Welcome back to Web Dev. Today we've got a short one. Right, a single command that does the job of a whole Perl script. So let's get straight to it. So now we're here in VS Code. If I expand the terminal, because we won't be needing any text editing, the whole crux of this is based around supplying the -e argument to the Perl program in the command line. And then with that -e argument, you can supply some Perl code, which will be executed. So let's write one. Firstly, I'm just going to make my terminal a bit bigger so you can see it. There we go, it should be big enough. And yeah, we start off by writing Perl as that's the program we're using, and then we supply that program with argument -e, and then we open up some single quotes, and this is where we're going to put the Perl code. So it'll effectively be like one line of a Perl script. So we want to print, open up double quotes, and then hello world. And remembering that because that's one line of some Perl code, we need to end it with a semicolon. So I click enter, we get hello world, but also we are getting that percentage sign at the end, which means that a new line isn't being printed. So I can go back to just after the exclamation mark, put a new line character in with the \n, press enter. There we go, get a nice hello world. In the last video, I said that Perl scripts should use the pragmas useStrict and use warnings. Within this command, they're not being used, so to include modules within your -e command, you can use the -m command. Now it's used slightly differently, so if I go Perl, if I bring up my command, so this was the working hello world. Now if I go to just after Perl, I go -m, now instead of there being a space, like just after the -e, we just start writing the name of the module, so -m strict. And then we can do it again for -m warnings. So if we were to create a much more complex line of code, then it would use these modules. There we go. On top of this, just like we can use two -m arguments, we can use multiple -e arguments. So if I bring up the previous command and at the end of it, write -e, I can then start writing another line of Perl code. So I'll open up single quotes, do another print, double quotes, and say hello to YouTube. There we go. Exclamation mark, new line character, and then a semicolon at the end. There we go. We have, there's a mistake, can't spell hello. There we go. We've got two lines of code, each printing to a new line using two modules. Thanks for watching. If you can like or dislike or leave a nice comment or a horrible one, it will be appreciated feedback. This is part one of 2 videos on scalars, and in this video we're going to learn first and foremost what a scalar is, what a sigil means, and what scope is. A variable in Perl is called a scalar. Just like other programming languages, we have a keyword, which is a word that the language uses to identify something. The keyword in Perl is my. my. You can think of it like a conversation. You are saying, my name is neddev. Let's go to the text editor and I'll show you how to use a scalar. So the first thing I'm going to do is create a document, a Perl file. So to do that, I'm in the terminal. I'm going to write touch and let's start numbering them so we have a useful bunch of files which tell us what things are. 01 underscore scalar. And there we are. So just like other Perl files, we need to use strict and use warnings. Okay. So let's tell the reader what we're about to do by using a comment. So what I'm going to do is tell this file that my name is neddev. So my, which is the keyword for variables, name, which is the name of our variable, and then that equals a string neddev. There we go. And we'll end that with the semicolon. Okay, so to make sure that this file makes sense and Perl understands it, let's run it. Perl 01 scalar. Okay, so it's telling us that there is a syntax error on line 5 near my name equals. So this is where sigils come in, which is the second thing I said we were going to learn about. A sigil is a way for Perl to understand what context you're your variable is in. So the sigil for a basic variable in Perl is a $, and that goes at the very beginning of the variable name. So just before the N, I'll add in the $, and then if we rerun the program, we can see that the program does nothing, but there were no errors. This brings us nicely onto the next thing I said we were going to learn, which was scope. So the definition of, or a simple definition of scope, is when you define a variable, as we've done here, that variable is available inside the scope that it exists within. Here you can see I've declared that variable within its scope, and its scope is the file itself. So anywhere else below it in this file, we can, well, I can prove to you that we can use that variable because it's in the same scope by printing it. So there we go. I wouldn't worry too much about what this is doing at the minute, but it's getting a hold of that variable and should print it out. There we go. Neddev. So what I'm going to do next is create a new block with its own scope. And to do that, I'm going to create an if statement, which you may have come across before, and we'll go into depth in another video. So that's just if, and then we want this to run every time, so we'll just say something that just is true. So 1 does equal 1, and inside here, inside this block, which I shall comment, so this is scope B. Let's say my dog's name equals Bernie. And first of all, let's try to get a hold of that variable from outside the scope that it's declared within. So let's test that definition. So if I say print dog's name, and then just some formatting to keep it clean, to test that definition of variables only being available within the scope that they are declared within, this should not run. This should throw an error. So let's run that. Yeah, dog's name requires a specific package name. So did you forget to declare dog's name? No, we didn't, but we did in fact try to use dog's name from outside of its own scope. So let's cut that out and paste that in within the scope, so within these enclosing parentheses, and run it again. There we go. So 1 equals 1 declares this, prints dog's name, and then prints name. So you get Bernie and then neddev. So another way to prove this is to declare two variables with the same name but in different blocks, and then we can see if they collide. So let's change that to name and that to name. So we've declared a variable called name here, and we've declared a variable called name here. So if we run this, they shouldn't collide because they both exist in, or are declared within, different blocks. So let's run it. There we go, and we get the same thing. Although, however, I don't recommend you do this within a piece of, or a script you're writing or a program you're creating, because it creates confusion, especially as things get more involved. So I'll just show you this file. Get rid of the terminal, and what we have here is 5 or 6 nested blocks, all of which run and all of which declare the variable name, and they are all assigned the name Pete. So if we run this, just from looking at it, you probably can't tell which Pete is being printed out from which block. So this is just an incredibly difficult to read piece of code. There's too much of the same thing, too many nests. It's just ugly to read, so don't do that. Welcome back to neddev. In this part 2 of Scalars, we're going to learn what types can go into a scalar. So let's get straight into it. So let's head to our terminal and create a new file. So touch02 underscore and then scalar types, because that's what we're going to learn. What types can a scalar can represent. Okay, so we'll click on that file, and just like our other Perl files, we're going to use strict and use warnings. Right, now, so let's make a comment so it's useful. Scalar types. So there are 3 main types of scalars and 2 other ones that will be used a lot in Perl. The first 3 are strings, the second one is integers, and the third one is a floating point number. Okay, so I'm going to make this terminal a little bit bigger so you can see it better, and I'm going to update this comment to say basic scalar types. So just like we learned in the previous video, we want to declare this variable using the keyword my and the sigil $. And we'll say my string. That's the first type of scalar we'll be using. We'll open it with quotes and we'll just write string, there we are, or str. That's a common abbreviation. The next one is, so my again, $, and integer. And an integer will simply be any number, so we'll go for 5. There we go. And thirdly is my and floating point, so I'll just write float. So a floating point number is simply a number with a decimal point in it. Practically, that's what it is. The scientific definition of is slightly different, but in programming, this is a floating point. 0.1, 0.0091, 1.00091. They're all floating points, but for simplicity, we'll just use 0.1. Let's practice printing these out. To do that, we'll use the print keyword and open up double quotes and then type our variable name, remembering to do a new line character because Perl doesn't do that automatically. And speed things up, we can just copy these down and change the name, so integer and float. There we go. So let's, for the first time, run this program, make sure it runs properly. There we go. So it prints out our 3 types. Another thing is not to get caught out thinking a number within quotes is actually an integer. A number within quotes is simply a string. So my string 2 with 5 in it, that is still a string. That is not an integer. Just like that wouldn't be a floating point, that would still be a string. So the next thing is to look at other types of variables. So let's create another comment. So other scalar types. Oops. And the first of these is an undefined scalar. So let's write that out. So my undefined equals, and then the keyword undef. So what do you think will happen when we try to print this out? Let's give it a go. So print and open our quotes, undefined, with a new line character and semicolon. Right, let's run this, see what happens. So there we go, use of an undefined, an uninitialized value, undefined. So that basically does what it says on the tin. You're assigning a variable undefined, therefore that variable isn't defined anywhere and you can't use it. So another common variable that you'll see is a scalar reference. It's quite common in a system to have maybe someone's first name and someone's last name, and then at some point within the system you want to concatenate those two to address them by their full name. So let's create two variables, one first name and that's me, and then last name. That's also me. And now what we want to do is create a scalar that references those other two scalars. So our third scalar would be full name. And what we do is we would simply write out the name of the first variable, then use the dot symbol as that represents concatenation, which is just bringing two things together. And we want a space between those two, and then the second variable. So let's print this out and see what happens. I'll just comment out this undefined because I don't want Perl to shout at me when I run this. There we go. So full name, I can add that in here. Full name is dot, and then our full name variable. There we go, neddev. Cool, so that's all the basic scalar types, and now what you've created is a useful reference file. The second of our useful reference files to go back to and learn from and look at and revise with. A Boolean is a basic data type with two possible values, true or false. So just like in the other videos, I'm going to create a file which you can then use to reference as revision or whilst you're writing other code. Right, so let's create a new file, which is num3, and call it Booleans. Okay, so let's open that up. Right, so in other languages, you are likely to get a bare word, what we call a bare word, which describes something to be, which will evaluate as true or which will evaluate as false. So in JavaScript, you might get a thing which is true, or equally you get another thing which is false. But in Perl, unfortunately, we don't have that. Instead, we have variables which return as true and variables which return as false. The easiest way to learn this in Perl is by starting with which things return false, because there are a select amount of things which return false, and then basically everything else will return true. The main four things in Perl which return false are undefined, so undef, 0, any amount of zeros, so it could be loads of zeros, or 0 within a string by itself. And then everything else is true, so I'll write that down. So let's test it. To do that, we'll set up an if statement, which we'll come across in a later video, but you'll just have to believe me at this point. So if, and then else. And so here we'll use the print statement, which we've learned, and say true. And here we use the print statement and say false. So what this if statement is doing, within these parentheses, we'll pass a variable and it will test if it's true. And if it is true, then it will print this. And if it isn't true, it will print false. So let's create the variable that will pass into it. Let's call that our statement. And let's test the first thing. So undef. We'll pass that in and then run the program. Perl 03. Oops, there we go. And so false. So that is correct. Let's do that to make it more obvious. Let's plug something else into this. So the next one would be 0, just the bare integer 0. That is also false. And then any amount of zeros. Let's add some more on there. False also. And then a string with 0 in it. False. Let's also test a string with no 0. False also, so we can add that one to the list. Okay, so now let's try any other kind of string. So let's just type string in there as a string. Rerun the program, so true. So string is true. Just to prove it, I'll do some gibberish. There we are, true. What else could we have? Let's have any other integer. So 1. That's also true. So now I'm going to show you some things that might catch you out, and they are that, well, 0 as a string by itself is false, but 0 with any other amount of zeros around it becomes true. There we go. So 0, 0 is true, but 0 on by itself is false. Another weird one is if you come into the language and you're expecting to use bare words, you might, for some reason, try and write false in a string. And if I put true, actually, then that will evaluate as true, but false, confusingly, will also evaluate as true. So here I've just written 2 other comments that will help me if I ever need to come back to this example file when I'm dealing with some other code and I need to understand how Booleans in Perl work. And they are the 2 rules that I just went over. So 0 as a string by itself is false, 0, 0 is true, and then true as a string is true, but false as a string is true, which is all a bit of a mouthful and quite confusing. So that's another reason why it's useful to have a set of example files. Okay, so that's it on Booleans. It's worth going through that and testing all types of different variables just to make sure you understand what evaluates as true and what evaluates as false. Welcome to neddev. Today's video is about arrays. So inside our development environment, we're going to create a new example file, and this will be our 4th file, and we'll call that arrays. Okay, so we'll open that up and instantly use strict and use warnings, just as we've done in all of the other files. So an array is much the same as it is used in other languages, except in Perl we use sigils, just as we learned in the other video about scalars having a dollar. The array equivalent is an @ sign. So let's make a basic array. So my @ sign, so this is going to be an array. I'll just call it that. And then what we can do is open parentheses, and just like any other language, we will separate the elements of the array using commas. So let's just do a couple of strings. So string 1 and string 2, closing it off with the semicolon. So that's a basic array in Perl. So now you might be asking, what can an array hold? So let's do list of things and open the parentheses, and so we know it can hold a string, it can hold a number, it can also hold a floating point, and finally another thing it can hold is undef. And what else can it hold? So another thing, a further thing is, let's make list of things 2. Actually, first of all, let's create a scalar. So this is thing equals, and then this will be just another string. Cool. And what we can do in here is create some elements, 5, and we can also reference this scalar as an element within the array. Okay, so this is just the arrays portion of our help file, and this next bit will be about accessing arrays. So to do this, just like in other languages, you use square brackets. So say we wanted to get string 2 out of our very first array. You might first of all think that we do this, and you'd almost be right. But this is where things start to get a little bit Perl, essentially, and what we would need to do is change that @ symbol to a scalar symbol, because what we are... there we go. So what we're doing is pulling this second element of this array and using it in scalar context. So it's now in the context of a scalar, not in the context of an array. So what I've done here is created a comment saying don't do this, because this is something that you should take forward in writing Perl. Is Perl will allow you to have a scalar. Actually, that's not very useful, so let's call that neat, and that can be a string. And it will allow you to create an array containing different array elements. Let's put that in there. Oops, sorry, let's change that to neat. And these are called the same thing, but exist within the same scope and are often quite hard to differentiate, especially when you start to come to access arrays. So you then might want to use in another piece of code an element of the neat array, so that would be in the scalar context and be neat, and you would access it with the access one of the elements. So these three things refer to something different but have the same name, which is just incredibly confusing. So what you wouldn't want to do is call these the same things. The final thing I want to show you is QW arrays. So let's do that. QW array. So QW stands for quote word, and what it does is it allows you to create an array without having to type out the quotation marks and commas. It separates the elements of the array using a space. So it's best if I just show you this. So let's quote word array, and then you would type QW open up your parentheses, and then you could just start typing. So each of these words is an array element. And then this would be exactly the same as if I was to wrap each of these in quotation marks, get rid of that, and then each of these words would also be an array element. But we wouldn't need to do that if we were just writing loads of strings. We could just type out the strings without all those extra characters. Another way you might see this written is with slashes instead. So quote word array slash, and basically once you've written QW, you can use many different characters to separate the start and the end, or encapsulate the start and the end of your array. And a common one that people may use is that. So each of these words is an array, and you could close it off again with the same element with the same character. So those two would do exactly the same thing. Finally, a little extra thing that might come in handy, or you might see, is returning the length of the array. So to do that, let's write out a title, if I can spell. Length of array is, so I would print, and then I would print in scalar context the array that you want to get the length of. So there we go. And let's make sure this formats correctly and run our file. There we go, 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's returning the correct amount of array elements from the array we created, one above. Welcome to neddev. This is Data Dumper in under 2 minutes. Data Dumper will essentially become your next best tool, and what it does is allows you to print nicely formatted data structures. So I'm going to create an example file called 05, this is the 5th tutorial, data dumper.pl, and then we're going to open that up once it loads, put in our pragmas, so use warnings, use strict. So the first thing you're going to want to do is import the library. So use data $: and dumper. And there we go, that's all you have to do to then start using data dumper tools. So what I'm going to do now is copy in 3 different types of variables. So first one is just going to be a scalar, simple scalar containing a string, and then we're going to have an array, different types. The last one we haven't covered yet is a hash, and this is a key value pair, and the last key's value is an array. But to print out this array and hash would require some amount of looping, and this is where data dumper comes in handy. So what you can do is write data dumper, open parentheses, backslash, and then the variable name. So let's put scalar in, because that's a nice easy one for it to do, and then run the program, and yeah, so we've got a string. Let's try it with the array. It's a bit bigger, and there we can see it's printed out. This variable is equal to these elements, as we can see down there. The last one, which is more complex, is the hash. So let's place the hash in there and run the program. And there we can see essentially a reflection of the data structure that we've built within the file. Welcome to neddev. This lesson's all about hashes. what they are, how to make one, and how to manipulate one. Okay, so the first thing I'm going to do is create a file 06 underscore hashes.pl, and when that loads, I'm going to instantly put in the pragmas use strict and use warnings. The equivalent to a hash in another language like Python would be a dictionary. So let's create a hash. First of all, we start with my, as we do with every other type of variable, and now we use the percentage sign to say that this is going to be a hash. And the hash is a sigil, so let's give this a name. So it's countries, and then we open up some brackets, and we can close them off with the semicolon. So our first key might be, say, England. Now instead of a colon, we use what's called a fat comma, which is an equals and a greater than sign. And then in quotes, if we wanted it to be the value to be a string, we could say this is a small country. And let's go to Australia, use another fat comma, and then say this is a large country. We separate them out with commas. There are other ways to do this, but this is the most common and most readable. So now how do we access a value within this hash? So if we set up a scalar and say size of England, and then that is equal to a $sign countries, and then we open up some curly braces and say, and put in the key that we want, so England. And this might seem a bit weird, but just with the arrays, we are accessing a scalar within this hash. Therefore, the context is a scalar. Therefore, we use a $sign. Let's make sure I've got everything right and print out that variable. So size of England and a bit of formatting with a new line. And let's run it. So Perl 06. Alright, so I have missed a T out of countries, so let's rerun that. Small. Okay, so our key there, the value of that key is small. To print the whole hash out easily, I'm going to use data dumper, as was in my previous tutorial. And what I'm going to do is get rid of this, print dumper, and backslash hash and countries. This is accessing. Then we want to know how to add. And to do that, we simply use this same syntax, but say we want this key, whatever it is, so we'll pick another country, say Peru, and we want that to equal to the key very large. So let's run this and make sure that's gone in. There we go, so we can see Peru as a key and very large as a value. Now let's change one of the values. So this is similar to adding, except instead of putting a new key in there, we use one that we already have. So let's use England and then add a very in there and rerun this. Cool. Okay, so we haven't then added another key to our hash. We've just manipulated the one that's already in there and changed its value. Final thing we're going to do is delete. So to do that, we use a delete keyword, and then we use the same syntax. So the name of the hash, curly brackets, and then the name of the key that we want to delete. So let's delete Peru. We can see Peru has disappeared from our hash. The last thing I want to show you is a QW hash. Similar to a QW array, I need to create the hash, hash of food QW, and using those QW and the brackets, we can open those up and say burger is 500, chips is 200, and cola is 400. I don't know. There we go, and then that would create a hash. Hello and welcome to neddev. This one's all about conditionals. Conditionals in Perl are much the same as other languages, except with a few added differences. We're going to learn about ifs, else ifs, and elses, along with a Perl specific one called unless, and also Perl one-liner if statements. So in our development environment, we're going to create a new file. This will be the 7th one, and we're going to call it conditionals.pl. Cool, so we'll open that up and put in use strict and use warnings. Let's start with a basic if statement. So we say if is the keyword, we open up some parentheses, and within these parentheses we want to create the condition when this chunk of code executes. So if what is within these parentheses evaluates as true, then what is inside these curly braces will run. If it is not, then it doesn't. So if you remember back to our Booleans session, we know that 1 will always evaluate as true. So let's make a statement. So it evaluates as true. Let's run this. 1207. So we can say that evaluates as true because it runs. If we put 0 in there, which we know evaluates as false, it won't run, nothing prints out. So that's our basic if statement. Now we want to move on to an if else. So let's comment that. So if we copy that down, and then we append onto the end else with just curly braces, and copy this print statement in and say false. And we run it again, we can see that it hits this one and evaluates as true. It also hits this one and evaluates as true. So let's put that to 0, so it evaluates as false, and then what is within this else statement will run instead. So there we go, evaluates as false. So when this evaluates as true, what's inside the first curly braces runs. When it evaluates as false, the second curly braces section of code within the curly braces run. Now let's look at if, else ifs, and elses. So again, let's copy down what we have above, and instead of having an else, or as well as, we have else if. Now in other languages it would be else with an E. In Perl for some reason it's else without an E. Let's open that up, put that back in, copy this print statement down, and just after the else if, we want to create another conditional. So it's if this evaluates as true, run this first bit of code. If that is false but this is true, we run this bit of code, and lastly if they're both false, we have the else and it evaluates as false. So let's put a 1 before that and a 2 before that, and say if 1. Then we can see 1 evaluates as true, so we print this line. let's put this to 0 and this to 1. We should see 2 come up, there we go. And if we put them both to 0, then it will evaluate as false. Another type of conditional within Perl, pretty much exclusively within Perl, is the unless statement. So this is essentially the opposite of an if statement. So if this evaluates as true as false, then it will run what's inside the curly braces. So unless that is true, run this. And what we can see here is, so Perl 07, then unless that evaluates as true, which it won't, it will print this out. So there we go, unless evaluates as false, which means the code block runs. If we put 1 in there, then it doesn't run. Lastly is a Perl one-liner. So if I wanted to, say, print out someone's name if something else was true, I would do my print statement, write someone's name, and then move on to the if statement. So that would be just like that. So if this is true, which it is, then it will print Joe. There we go. And if it is false, it won't print it. And opposite to this, we have an unless statement in a one-liner. And let's say ned, and because that evaluates as false, unless it is true, which it isn't, it will print ned. There we go. A word of caution though, unless it's pretty awkward to get your head around, even though it's just the opposite of an if. It can make things a bit hard to read, so err on the side of not using them. Hello and welcome to neddev, where I try to make complicated things practical. So today I'm going to talk about array functions in Perl. There are 4 main types of array functions in Perl. These are pop, push, shift, and unshift, as you can see on the left of this diagram. Each of those white boxes in one horizontal row is an element. So pop will take out the last element of that array. Push will put an element into the end of an array. Shift will take out the first element of an array, and unshift will put into the first element of an array. Now that'll all come clearer later as I go through each of them individually in more depth, but this is a good diagram to come back to once you have an understanding of what each of them do and you just need to jog your memory. Let's start with pop, and what pop does is permanently remove the last element of an array. So if I run this animation here, you'll see if I put pop onto an array, it will drag that last element out of it. Over in our development environment, let's create a new example file that we can use to reference in the future, and we'll call this number 8 and array camel case function.pl. Okay, let's open this up, put in our pragmas and use strict. Amazing spelling there. And here we can start writing our first array function. So what we're going to do is create an array, dump that array out to the console, and then use pop on that array and then dump it out again. And then what we should see in the console is what the array looked like originally and then what it looked like after we enacted that specific array function. So to do that, we'll start with creating an array using the sigil at, and we'll call that array pop, and open it up, put in some strings. So ned can be the first element, dev can be the second, and pies can be the last. And what we'll use to dump it all out is data dumper. So we'll include that using the use keyword and print this to the console. So print dumper backslash and reference pop array. Cool. Okay, let's test this out. So Perl 08. Okay, cool. So we can see that in that variable we've got ned, dev, and pies as our data structure, as our list array. Sorry. So now let's use pop on this. So all I have to do here is use pop, open parentheses, and then pass in my array. So array pop. And then what we'll do is we'll copy this dumper line, copy it below, and run the script again. And then we can see, just as the diagram said, we've pulled that last element out. So before we move on to the next array function, I want to make it clear that this function here returns that last element. So we could assign this this function call to a scalar called array pop underscore scalar, and equal that to the function. And then what we can do down here is print out that array scalar and run the file again. And there we can see, so in our first print it dumped out all three, then we used pop, it removed that last element, and in doing so it returned to our scalar that last element. Let's start talking about push. So push is essentially the pair to pop. So push and pop both act on that last element of the array, and instead of pop pulling that last element out and returning it to you, what we're doing is supplying an element and pushing that into the last element of the array. So as you can see here in this diagram, that last element we're supplying is being pushed up into the array. So now I want to make this example file usable, so I'm going to comment this as pop and comment below as push, and even maybe create a simple print statement that says pop ... and then a new line character. And what I'm going to do is copy that down, being lazy, and put push. So when we come to run this file in the future, maybe we've forgotten what these array functions do, and it's really obvious from our notes that what is happening and what's being displayed. Okay, so here I'm going to create another array. So just to be lazy, I'll copy this down and I'll call this array push. We'll change these elements to fish, chips, we'll keep pies because that's in line, and we will dump this out again, also copying down that dumper statement. So array push. And what we can do is run this, so Perl 08, and we can see fish, chips, pies are our elements of that array. Now let's do a push. So with push is similar. We say the function name, we open some parentheses. The first argument is what array we would like to push to, and the second is the element that we'd like to push into the array. So let's go for a source, so ketchup, and close that off and dump it out again. Now what we should see is ketchup move up into this array as the last element. There we go. So variable 1 is fish, chips, and pies, and variable 2 is fish, chips, pies, and ketchup. Opposed to the first two, which can be thought of to just affect the last element of an array, shift and unshift work on the first element of an array. So if I play this animation here, you'll see that the first element gets pulled out of the first position of the array, so the 0th index, and then that returns to us, and we can use that element just as we could have used that pop element from. So here I'm just going to create, just as I've done with the other ones, another heading to keep things clear, call it the right thing. Copy down this, change it to shift, and we'll make another array and call that array shift. Now let's try something different. Let's go for blue, red, and green, and we'll dump it out. Shift. There we go. So Perl 08. And then we can see red, blue, green as our element of our new array. So just with pop, what we can do is assign shift scalar. We can assign what's returned from the function to a scalar, because the function returns the element that is grabbing from the array. So we can go shift and put in array shift. There we go. And let's dump this out. And then let's also dump out the scalar. Remember to change the sigil. So what we should see now is, yes, so we've got all three elements, then we've got two elements because it's pulled the first one out of the array, so that's red, and then it's used that return to assign to array shift scalar and print that out. The last array function is unshift, and this is paired with shift because shift pulls that first element out of the array and returns it to you, whereas with unshift we want to supply some data and put that into the array in the 0 index, so right at the beginning of the array. And if I play the animation here, you'll see that that element gets unshifted into that array. Okay, so we know the drill now. Let's create a new heading and copy down these two, or these three in fact, and let's add unshift, unshift. We'll keep the colors here, and we will change this as well. Okay, cool. So let's run this. What we've got is unshift, red, blue, green, just a simple array. Now to use the unshift function, we need to first use the name and then supply the array that we are unshifting to. So array unshift, and then in the second argument we want to supply the data that's going to be unshifted into the 0 index position of that array. So let's go for purple. And what we can do is dump it out again. Cool. Okay, so in that very first position, we have unshifted all of those elements up and put that purple element into the beginning. Welcome back to neddev. Today we're going to be talking about ternary operators. These are essentially pushing a whole if-else statement into a one-liner. I often find ternary operators really hard to read, and I'd love to just say ignore them and write more readable code, but they are in fact used too often to just gloss over like that. So firstly, we're going to go over to our development environment and write an if-else statement to start with. Right, so within this file I'm going to create a scalar called, thing, and assign it an empty string, and then start an if statement with 1 being the Boolean equivalent of a true, or the Perl Boolean equivalent of true, and let's assign thing to the string ned. And let's write an else and assign, if it's false, dev. Cool, and print that out. So print thing, comma, and a bit of formatting for the new line character. And let's try that out. So Perl 09. Oop, I have used square brackets there. That's a mistake. Okay, so ned, and let's flip this to a 0, so it's false. So that if isn't true, so it uses this else statement, and then we get dev. Perfect. Let's squish these 1, 2, 3, 4, 5, 6, 7 lines of code into one using a ternary operator. So let's go into 2 lines of code, a ternary operator and a print statement. Let's go my thing 2 is equal to, and what we can do here is start the ternary operator, so that would be, let's say, 1 question mark. I'll explain what this means in a second, and then ned and dev. Let's print thing 2 out. Cool. Okay, so what we have here is this is false, so it's printing out dev, and this ternary operator is true, so it's printing out ned. And if we were to flip this, then we would get dev. So what's going on here is we have a ternary operator which is defined as a question mark and a semicolon, and then around those two things we have the conditional, which is this 0 here, 0 or 1, and then we have what happens if that conditional is true. So this question mark is sort of asking the question, is this conditional here true? Then we give this. If it is in fact false, so 0, then we give what's on the other side of the semicolon. So it might be a good idea to stop here, pause, and just try to write a few of these, and you can find other things from the Boolean episode where conditionals are evaluated differently, so you can make some kind of more complex naming program so you can practice this. But if you're comfortable with that, then we can move on to a more complex form of ternary operator, which is essentially squeezing an else statement or longer into a single line. So what we can do is start by just writing an else if ternary operator. Cool. So let's do that. So if 1, so if true, then we will assign our new scalar thing 3, which is empty here. We will assign that to ned, and then we'll do an else if, which is we've said is true there, and we'll assign thing 3 to assign it to something totally different, water bottle. And lastly, if they're both false, then we will assign thing 3 to dev. There we go. Let's try printing this out. So print thing 3 and some formatting. There we go. Cool. Okay, so this last one down here, we can see ned. So this is true, therefore thing3 becomes ned and it prints that out. So let's flip that to false. And we should see it turn to water bottle, hitting here because this is true. Turn that to false. Then we can see that it becomes dev. So it goes through each of these two tests and does what's left, so the else. Right, let's squeeze this into a ternary operator. So what we have, what we need to do is create another scalar. So my thing 4, very creative names. Nope, so we say 1, and our ternary, and we shall say ned. That's our first one here. If that's not the case, then we can say, we can test another condition and say that is water bottle. And if that's not the case, then we can say it is dev. Let's print this out. So thing 4. Cool. Okay, so that's true. So it's ned. Let's change that to 0. And then it becomes water bottle because this is true. Say that is 0. And then it becomes dev. So what's happening? What we are doing is essentially squeezing another ternary into the else. So if we look at this one, when this isn't true, it becomes dev. But what we're saying is when that's not true, we create another test and say, well, if this is true, then we do one thing. If it's not true, we do another thing. And you can chain these onto each other with your heart's content. But chained ternaries are just incredibly confusing to read. If this came up in a piece of code, it would take a few seconds to understand, whereas although it takes many more lines of code, I can instantly know what's going on here with an if, else statement. It doesn't matter how long it is, you know it's hitting one thing and then you're going down testing conditionals. Hello and welcome to neddev. This episode is about command line arguments. If you spent any time around a command line like this, you'll know that commands often have additional properties called arguments. These arguments are often preceded by a dash and then a letter, especially in Linux. So a common command in Linux is ls, and what that does is list the files in whatever directory you point it to. So there we go, I'm just lsing what's in this neddev folder, and it's giving me in alphanumeric order the names of the files. But say I wanted to sort those files by size, I could pass in an argument, dash s, capital S, and then that would give me back the files with the largest size down to the smallest size. So what we want to do now is understand how to harness that ability to understand to use these arguments within a Perl script. Okay, so just as we've done with every other video, we're going to create a new file, and this will be our 10th example file. And we'll call this command line args.pl. And when that loads, we're going to put in our pragmas, use strict, and use warnings. Okay, so also, to make this a bit simpler, we're going to use data dumper. I think this is the simplest way to show you how this works. Now, command line arguments in Perl are stored in the array argv. So to show you this, I can print out argv. So that would be our sigil at, and then argv. Now if I run this, nothing is within it because we haven't passed any extra command line arguments into our command line. So if what I did here is write hello, then we can see that it's dumping out all of the elements within the argv array, and of which there's only one. I can also put hi, howdy, and there we can see each new command line argument is just being added as a new element in that argv array. So what if we want to access an individual element within that array? We simply treat this argv array as a normal array. So we can say something like first lm is equal to, we're in scalar context, and argv, and then access that the index of that array. So let's say the first one, and print this out. So first lm, a new line character, and then it will print out hello because it's accessing the first element within the argv array. A slightly cleaner way to do this would be to use the syntax where we can assign multiple scalars in one declaration. So we say my open parentheses and then say first array lm, and then we can say second in a new scalar, second array lm, and then this will be equal to argv in array context. And what we can do is print this out so I can prove it to you. So get both of them down, split them with a new line, put a new line at the end, and there we go. So what I'm going to do now is create a new program called, let's call it count word length .pl, and I'm going to open that up and use warnings and use strict, and what we're going to do is essentially copy this and then print out the length of whatever argument we put into the program. So let's say my open parentheses word is equal to argv, and then what we can do is print out the length of word, and then a bit of formatting. So Perl count word length, and then we're going to pass it a variable. So let's say neddev or ned, and ned has 3 characters in it, so it's printing out the length of that argument going through. Now this works relatively well, but there is one main problem with it that I think you should play around with this program and see what it is. Hello and welcome to this short Perl 5 tutorial on the keyword die. As well as die, we'll also dive into using other keywords such as defined and not. It's pretty much as it sounds. If your script was a living thing, this command causes it to cease to live. So what I'm going to do is create a new file. So this is the 11th tutorial, and this will be, we'll call it die. So there we go, open that up, and what I'm going to do is copy in this word length counter from the previous command line arguments tutorial. And a little refresher on what this does is if I run it, there's an error, so that will be a clue, and then if we put die, there are 3 letters or 3 characters within our argument, therefore it's just printing out the length of that. It's quite simple. But as you can see there, when I ran it with no argument, I get this error. And if I was a user who didn't understand this error, it's not very useful to me. Reading that error, I don't know what that script should do. In order to protect the user from getting this not very useful error, we're going to test whether they've actually passed in an argument or not. So what we want to do is make the script die with a useful error if this word is actually defined. So what we need is an if statement with a conditional, the condition being if this word is defined. So we could say not defined and then say word, and in here we can say die, and to use this we simply write the keyword and we can open up some quotes and say error, please pass in a command line argument with a new line character at the end, and so we can say if this isn't defined then the program will die. Let's try it out. There we can see it works. If we take away that argument, error, please pass in a command line argument. And now the user knows what they should be doing differently to use this script properly. And the last thing I'm going to show you how to do is to put this into one line of code. So all we need to do is copy this out and then say if not defined word. And I think this actually reads quite nicely. So there we go. And ned and 3. So our program still works, and with this one-liner we're just saying if not defined word, then die with this error. So as a one-liner, I think this works quite well. Hello and welcome to neddev. The next few videos are all about loops in Perl. Today is while loops. Like an if statement, except it will keep testing the condition and running the block if it is true. So over in our development environment, I'm going to create a new file called while loops, something that we can reference when we come back to learning this. So use strict, use warnings, and I'll do a little refresher on how an if statement works. So if this is true, then do this. So that should be a hash. There we go, I'll do. And a while statement is essentially the same structure except using the while keyword. So we'll do while, open parentheses, and if this is true, and then we then do this. So that's the basic structure of a while loop, and the key difference is that a while will keep testing to make sure this is true, and then when it isn't true, it'll move on. So let's comment those out and write an actual while loop. Let's say we're writing a game and we have a tree that is 100 centimeters tall. We want to see that tree grow and then stop at a specific height. So what we can do is use a while loop and then say if this tree is less than 1,000 centimeters, so 10 meters, then we want that tree to grow. So we could go tree is equal to the tree plus 100 centimeters. and then we'll print this out each time so we can see it growing. So we'll go print double quotes, my tree is tree centimeters tall, new line character, and we'll put a print here to say moving on, just to show you that the code gets stuck essentially within this while loop whilst it's going on. It doesn't move on to anything else until this is false. Cool. Okay, so there we can see the tree has grown up to 10 meters tall, and then our code moves on. Similar to an if, the opposite of an if statement being an unless statement, the while loop also has an opposite. And the opposite of a while loop is an until. And how an until works is, instead of a while loop working every time this condition is true, an until loop works until it is true. So meaning every time it is a false, then it runs. So let's create another tree. So new tree, and same starting height. And what we'll do is say we want to achieve the same thing but using the opposite logic. So we want the tree to grow to 10 meters in 100 centimeter increments. So we can say until the tree is greater than 1000, meaning it will start off by being false because we've got a 100 centimeter tree and which is less than 1000. So this will then run, and we can do the same thing. New tree, and do the same thing in there. And what we should see is, so this tree then tests to see if it's greater than 1000, and because it isn't, it runs the code, instead of the opposite of a while loop where it tests to see if this is, and then it runs the code. So there is actually an issue with this, and I'll see if you can get it before I tell you. So pause the video and see if you can fix the issue here, because we want this tree to be 1000 centimeters tall, just like our first loop, but instead it's going up to 1100. So hopefully you've already got that, but what we need to do, because this is executing once more, because it gets to 1000, and then it says, is this greater than 1000? And 1000 isn't greater than 1000, so it adds another 100 centimeters to the tree before it stops the loop. So what we need to say is if this is greater than or equal to. And then if we run this, it should get to 1000 centimeters. Hi and welcome to neddev. This video is all about C-style loops. They are called C-style loops after the programming language C and how the syntax was originally implemented there. So if you've come from writing C or have some experience in it before, you can probably just take what you know there and put it into Perl with a few tiny tweaks, and it works the same. So let's create ourselves an example file. And to do that, I'll just touch a new file and call that C-style loops. Cool. Now we'll open this up, use strict, use warnings, and firstly we'll start with the structure of a for loop. Now the structure of a for loop is similar to this when making an if statement or a while loop. So we use the keyword for, we open parentheses, and we open some curly brackets. Now this is the bit that really makes it a C-style loop, and it's what goes inside the parentheses here, and it can basically be broken down into a start, a stop, and a step. What are each of these things? So start is where we initialize a variable and say the for loop needs to start here. Stop is the condition by which the for loop will continue. So if it returns false, then the for loop stops. And step is by how much the iterator, what we initialize here, goes up or down by. So let's create a for loop for real in Perl. What we're going to do is create our structure. So we'll say for open parentheses and then open curly brackets. Now in here, the first thing we want to do is create that start, that variable, that iterator. And we do that by declaring a variable as we would anywhere else in the piece of Perl code. So we'll say my $, give the variable a name, we'll say I for iterator, and we'll equal that to 1, and then we close it off with a semicolon. Let's give our for loop a comment, say what it needs to do. So count up from 1 to 10 in increments of 1. And so the next thing we need to do is create the stop. So this for loop will continue to work whilst this condition is true. So we'll say whilst I is less than 10, that is our condition. So that's when the for loop will work. And we want it to go up in increments of 1, which would be I, and the shorthand for this is plus plus. So let's print this out as we know how to do, and run it. So Perl 13, and what should happen is it should count up from 1 to 10 in increments of 1. There we go. So it's gone 1, 2, 3, 4, 5, 6, 7, 8, 9, and hasn't reached 10. So what we want to do here is say, well, either put this up to 11, or we could say it is smaller than or equal to 10, because we want it to print out 10 when it gets to it. There we go, so we get 10. So let's recreate this, but not use this shorthand. So this shorthand is another hangover from C. So we'll say I equals I plus 1. And then what that will do is take I and add 1 to it each time we iterate over. So let's run this, and it should count from 1 to 10 up here, and then count from 1 to 10 down here in exactly the same way. There we go, so 1 to 10 and 1 to 10. So what happens if we want to go up in increments of 5, say? So let's change our criteria and say 5, and change that to 5. We should see down here, gone 1, 6. So let's try another one. So let's try to change this statement and say count down from 10 to 1 in increments of 1. So first of all, we need to initialize. Let's rewrite this. So let's say my iterator, doesn't have to be I, could be x is equal to 10, because that's where we're starting. And then we want to say whilst x is greater than or equal to 1, we want this loop to run, and each time we iterate over x, we want to take 1 away from it. So that could be this, or the shorthand is x minus minus. So let's run this. There we go, so 10 all the way down to 1. Hello and welcome to neddev. I'm Ned, and this video is about for each loops in Perl. Let's create another example file so we have something to look at later on and reference. So I'm going to go touch underscore and for each loop Perl script. There we go. I'll open that up, put in our pragmas, warnings. I made that capital. Right, so what a for loop does is, instead of a C-style loop where you declare a variable and then set the parameter for it to stop and the increment by which it goes up, in a for each loop, what you do is you supply an array, and it works through that array from element to element from start to finish. The basic structure of a for each loop looks something like this. So you've got the keyword for each, and then we have an iterator, some parentheses where we pass in an array, and then we open up some curly braces, and this is where we put our code that we want to execute in each iteration of that array. We'll now comment that out and create one for real. So firstly, we need to have an array to pass the for each loop. So my @ symbol is the sigil array of animals, and that could be equal to some elements. So we'll go for small animals, hamsters and rats. There we go. Small rodents. And now we'll write for each, so our keyword, and then this is where we define our iterator. So we go my, say, animal in array of animals, open up parentheses, and we can print out each of those animals. So we can say print animal, and then do a new line character. So Perl 14. There we go. So what happens is, in each iteration of that for each loop, an element from the array gets passed into our iterator, and then we print that iterator out. So functionally, there is absolutely no difference between using for each keyword and for keyword. So if I run this, we get exactly the same thing again. So these two are completely the same. The last thing I want to go through is the difference between using an explicit, so let me comment this in here, explicit iterator. So this is where we define what the iterator is and use it within our code. And then there is implicit iterator, and this is where we never define this. So the structure of this would be for each or for, and then array, and then our code. So there we go. And what happens is Perl puts each of the elements it's iterating into a predefined variable. Let's write one of them now. So I'll comment this out, and we can say for each or for, and let's define an array. So let's make this an array of numbers from 1 to, let's go up to 10. Say numbers. And now you might be wondering, how do I use what I'm iterating over? So the predefined variable is $_, and this is where each of the iterations will be stored. So let's run that. There we go. So we can see that it's iterating over each element in the numbers array, and we're printing out that iteration all the way from 1 to 10. That's all. Thanks for watching. For each loops are used everywhere and are super useful when iterating through arrays. Hello and welcome to neddev. This episode is about subroutines in Perl. If you've done any programming before, it's likely you've come across functions, and subroutines are just Perl's equivalent of a function. Functions or subroutines are used to do a specific job, This reduces the need to rewrite code when that job is done multiple times. So in this episode, we'll go through the functions themselves, unpacking arguments and returning values, and what all of that means. So over in our development environment, I want to create another example file that we can reference later on. So this is our 15th, and I'll call it subroutines. And then, like all of our other files, we need to use the pragmas use, strict, and use warnings. So as we did with if and while statements, we're going to start off by learning the structure and the syntax of a subroutine. There we go. And so how this works is you have the keyword sub, and this is like in other languages where you have in Python, say def, and you're defining a function. Here we're defining a subroutine. So, and then we say the routine name, and then we simply open a scope with curly braces. And inside these braces is where our code that runs lives. So the next thing we want to learn is how to call this, because as it's set there, this is just a defined piece of code that we can call. It doesn't just run. So if I was to run this, nothing happens. Even if I put in here print neddev, that won't run until we call it. So to call it, we use the subroutine name and open brackets and then close off that statement. And if we run this, then it runs the code. It's worth noting at this point that if you come across some old Perl code, it may look something like this with an ampersand at the beginning, and they will both run. There you go. But this is the old way of doing things, and you shouldn't use it now. So this is simple enough to understand, but let's make a subroutine which takes in an input and does something to that to give an output. Those are known as arguments that you pass in. So Perl being Perl has a different way of doing things. Instead of having, say, function, the function name, open brackets, and then you pass in these inputs with arguments like that, and then use them in the function body. Instead, what we need to do is unpack the arguments. Now, if you've watched my episode on arrays, that'll help a lot, because you do a similar thing. Arguments are passed into a built-in array, and then you take them out and use them within the function. So let's create a subroutine which makes things uppercase. So we pass in a word or a string, and then it makes that string uppercase and prints it out. So, as we know, keyword sub, and then make uppercase, and then we open the body. So there are two ways of doing this. What we can do is, I'll show you the two ways in parallel. So we can say my open brackets and string, or whatever you want that string being passed in to be called within the function body or the subroutine body, and then @_. And this @_ contains our arguments. So if we pass in a single argument, that will be the first element of this array. If we pass in two, then there will be two elements within this array, and we could do something like string 2, and then the first element will be passed into the first declaration here, and then the second one into this. So another way to do this will be to use the array function shift. So we could say, if I get rid of that to make them equal, so string with no brackets, and then I say shift. Because if you remember from that previous episode, shift will take the first element of the array and everything else shifts up one, and then it returns that first element to whatever you want to use it. So here we're assigning that to a variable called string. Right, so now what we want to do is use this string and make it uppercase. So we can go print uppercase, which is a function all by itself, and then a string. And we'll do a new line character to keep things neat. And we can copy this down into here, and we can call that function. So let's call this make uppercase 2, just to differentiate between them. So we can copy that name, we'll do it here, that might make it a bit simpler. Then we can pass in a string, so say ned, and we can do the same thing here. Pass in a string dev, close those two off and run it. So now you can see I've passed in a string which contains lowercase and a string which contains lowercase down there, and they both get printed out in fully uppercase. It's worth me noting that there are more methods than this, so this is just my preferred method. I think it's the cleanest and scales the best. This is another method that I see a lot, and there are other ways to do it. You are simply just taking that array and doing something with it. These are commonly used ways to use an argument. So you might be asking, can we only pass strings into or scalars into a function? And no, we can pass in anything we like, really, as long as that function is ready to deal with whatever you're passing in. So let's make a subroutine for print hash. So in here, what I want to do is I want to accept a hash. So I can use this similar to this first method, and that can be equal to my array. So each element in this array will become a key and then a value within that hash. Right, let's actually do what the function is meant to do, which is print out our hash values. So let's create an iterator and say for my keys, in only the keys of our hash, and what this will do is iterate through the keys of that hash, so then we can access the values of the hash using the keys. Oops. So we can go print and say our hash access the scalar within that hash with the key. Actually makes more sense to call that key rather than keys. And let's do some formatting, create a new line value. So the next thing we want to do is to create a hash to go into this function. We can do that by saying hash of names, and let's just number them. So key 1 is equal to value ned, key 2 is equal to value dev. Close that off, and now we will call that function and pass in the hash that we've just created. So hash of names. There we go. So let's print that out and see if it does what we want it to do. There we go. So we get dev and we get ned. So far we've just been printing things out from our function. Now most of the time when you come across a Perl project or you create one, you won't necessarily want to just be using a function to print things out. You want to use a function that you give an input and it gives you something back that's useful to then use within your program. So let's comment this out and let's create a mathematical function that sums array elements. Yeah, okie dokie, so there we go, and as you can see there, we want to pass in an array. It expects an array. We can say array, that can be called whatever you want, but it makes sense to call it array in this context, and we assign our built-in array to our array to use within our function. Now you could just access this directly within the function, but I think it is a lot more readable and cleaner if you assign it to something else with a meaningful name. So the next thing we want to do is sum up the elements within this array. So we can say, let's create a running total. And that can be equal to 0 because we've got nothing in there at the minute. And then we can iterate over this array by saying my x, that can be our iterator. We'll pass in the array there. And for each element that we come across in this array, we want to add it to our running total. So we can say our running total is equal to whatever's in our running total plus whatever's in our iterator. And that should do for that. And finally, is what we want to do is give this number back to, because we don't just want to print out the running total, we want to return this number, this total, back to the program that's asked for it. So we can say the keyword return. This is much like other languages, so we can say return and the running total. Cool. Okay, so let's create an array, and my array of nums equal to 5. Okay, so that we know should equal 1, 3, 6, 10, 15. So our function should return 15 if it's written correctly. So you can say that, and array of nums. And there you can see. So we don't know if that's run correctly, because what it's done is returned that number to where we've called it. So to then access that number, we can then print this out. Cool, 15, so we know that works. Returning is effectively exiting that function. So if I was to put a return here and say return finished, then as this executes, it would get to this line, return this, and not execute any of that ever. So you have to make sure you put the return in the right place, and usually that's at the end after you've done anything. So there we can see finished. Now if I was to put this after our other return, then we will get the right answer and we would never get this. Thanks for watching. I know that was a long one, but functions or subroutines are so important and so foundational in programming, it makes sense to spend a disproportionate amount of time here. So please like, dislike, comment and subscribe, and I'll see you in the next one where we'll talk about standard input and standard output. Hi and welcome to neddev. Today is a short one all about standard input, standard output and standard error. If you've used any kind of shell program like Bash or PowerShell, then you'll likely have come across these concepts. So standard input is your input from the keyboard, can then be used within a program. Standard output is, say, where your print statements are going, and then standard error is where you would log any errors or extra information about a program. Over in VS Code, I'm just going to create a new file that we can put everything we learn within the episode. So touch 16, it's our 16th file. So open that up and put in our usual pragmas and use warnings. So the three things I talked about at the beginning were standard in, standard out, and standard error. And we'll go through each of these one by one, using them within a program. So the first thing is standard in. Now that's taking information from our keyboard and using it within our program if that's what we want to do. So we can say my input, we can assign this to the less than and greater than sign, and within those two signs we can say stand in. Now in VS Code this turns blue because it is a keyword within Perl, so it's just doing some syntax highlighting, and we can then print this out. Oops, inputs, and run it. So Perl 16, and now it looks like our console is just frozen. So what it's really doing is it's getting to this line here and it's expecting some input from the keyboard. So what we can do is then say hi and enter, and then what it does is it moves on to this next line and prints out what we just put in, which is hi with a new line character, because you press enter to enter that into our program. Something you may come across when reading other Perl files is something similar to this or related to this, but not the same. So if I copy this out, comment it, and put it down here and remove stand in, and then run this, it's exactly the same thing. We get the same answer. Now, in this very instance, it works in exactly the same way. But if you come across these two in another Perl file, it just gives you a starting point. It's similar to what we're doing up here, but not quite the same as. Okay, moving on. So we'll move on to standard out and standard error, because these two are related. So what we've done just up here is implicitly sent the input to our standard output. Now to do this in an explicit manner, firstly I'll create a new variable. So let's call this name and say neddev. And what we can say is we want to print out name to our standard out. Now when I run this file, it will, forgot a new line character, it will print to the standard output, just the same as this would. Okay, so we've worked that out. Now what about standard error? Let's create two new variables. Let's say fname is equal to ned, or actually let's say that's equal to ned, and this new one is called lname. I'll call that dev. Now below, what we'll do is print out to both standard output and standard error. We'll just copy this down, say standard error, say lname. Cool, so let's run this program. Now we can see they've both printed to the same place, which might seem odd because they're two different file handles that are meant for different things. Now they are being printed to the same place in the end, but they are not going via the same route. Now I can prove that to you on the terminal. So if I run this program and send it to a info.log file, we can say, using the greater than sign, what this does is it pushes any output into the info.log. So now what the first thing we see is that only dev printed out standard error, which means that standard out is being moved off into this info.log file. Now we can see we have ned. So let me delete that info.log file. And what we will do is say 2. And this is the other route that I could take. And now we're only getting ned because standard out is not being pushed into anything, but standard error is, which is our second possible output route. Now coming to info.log, we've got dev. Okay, so let's use everything we've learned and write a little program that contains all of the standard input, standard output, and standard error. So to do this, I'm going to firstly print to standard out and say, what is your name? We can quickly just test this. What is your name? Fine. And then we can say my name as a scalar is equal to whatever the standard input is after we print out the question. So we can say ned. And nothing's happening with that. So let's test to see if the user has actually written anything. So if name is not equal to no string, so if it contains some words, we can say print to our standard output and say your name is and name. Else we can print to the standard error and say please enter a name. Right, let's test if this works. So what is my name? My name is Ned. That's fair. And do it again. We can say just click enter. Oh, now it says we have an error because I entered nothing, but it still says your name is something. So in here, I think we need a new line character. So just enter, and then it says, please enter a name, because all we've done is click enter. So if your name is not equal to only a new line character, then please enter a name, or rather, next time you run the program. And here what we have is just a simple program that demonstrates how to get a standard input and sends to our standard out or standard error. Hi, welcome to neddev. In this video we're going to talk through basic file handles. This is how to open, manipulate and close files on your local system. So the first thing we're going to do is create a new test file, so we'll call this file handle. We'll open this up and put in our pragmas. Okay, so we're ready to go. Now part one will be just opening a file. So we've got this log file here. It's got nothing in at the minute, so let's put hello from the log file. Now the first thing we want to do is have our script understand where this file is and open it up. So to do this, we'll use the built-in function open. Now open takes three arguments. The first is your file handle. So this is the variable by which we're going to manipulate that file with. So we'll call this fh for file handle. The next argument is how we're going to open this file, what we're going to do with it. So there are a few main things, but we're just going to start with the less than symbol. And this is simply, we're going to open it up and read from it, read only. And the last argument is the location. So we'll just go to our current directory and say info.log. Now close that off and we'll just run this. Right, so the next thing we need to know how to do is read that file. Now I'm going to show you two different ways. The first way is possibly the easiest way. So we make a simple print statement and we use the read line symbols and pass it our file handle. Now what this will do is just print out each line of our file. So the second way, and probably the most useful way, is, unless you just want to see the contents of the file, is to use a while statement. So while, and then we open up the parentheses and we use the same read line symbols. So, and in here we do exactly the same thing. So whilst it's reading in the lines, we can print out the built-in variable. And that should do it. So I'll just comment this one out. And there we go again. So we get each line from that file. Okay, so now we know how to open a file. We know how to read a file. Now we need to know how to write a file. So to understand how to do these things, we need to understand the second argument. And the second argument is the file handle mode. So what we have is less than is, put that in quotes, less than is read only. A greater than is create a new file if it doesn't exist, or remove all contents if it does. So let's practice that one. I'll just give you the last one straight away. So the last one would be also create if it doesn't exist, and append to end of file. So this one will just keep the contents of the file and keep adding to the end of it. Right, so let's open a file in the write mode. So that would be greater than, and we will create a new file called infolog2 with a new file handle 2, and then what I want to do is print using that file handle with no comma there, and say new log file. Okay, so let's test that out. So down here in our directory we can see info.log2 got created and new log file was put in there. So what happens if we run this again and put new, or write something completely different, so neddev vid. So the file stays, but it totally overwrites what's in it. Now let's change that and say append to. So, and let's put the same thing in again. So if we run this again, we should expect to see this string appended to the end of this file. Let's go back to here. Yeah, so we've got the same thing again. And lastly, this is a short script, so when the script ends, the file is closed anyway. But if you're in a more complex program that needs to write to logs, or multiple parts of a program are writing to logs separately, then you need to make sure you close that file handle so something else can read the file. And to do that is simple. You just write close, and the first argument is your file handle. So let's say file handle 2. That would be close the file handle. Oops, so we need to put that at the end, and what that'll do is just make sure we can't write to it. So to prove that, I can put this here and say, there we go, print on closed file handle, because we can't write to fh2 after we've closed it. Hi and welcome to neddev. In this video we're going to talk through basic file handles. This is how to open, manipulate and close files on your local system. So the first thing we're going to do is create a new test file, so we'll call this file handle. We'll open this up and put in our pragmas. Okay, so we're ready to go. Now part one will be just opening a file. So we've got this log file here. It's got nothing in at the minute, so let's put hello from the log file. Now the first thing we want to do is have our script understand where this file is and open it up. So to do this, we'll use the built-in function open. Now open takes three arguments. The first is your file handle. So this is the variable by which we're going to manipulate that file with. So we'll call this fh for file handle. The next argument is how we're going to open this file, what we're going to do with it. So there are a few main things, but we're just going to start with the less than symbol. And this is simply, we're going to open it up and read from it, read only. And the last argument is the location. So we'll just go to our current directory and say info.log. Now close that off and we'll just run this. Right, so the next thing we need to know how to do is read that file. Now I'm going to show you two different ways. The first way is possibly the easiest way. So we make a simple print statement and we use the read line symbols and pass it our file handle. Now what this will do is just print out each line of our file. So the second way, and probably the most useful way, is, unless you just want to see the contents of the file, is to use a while statement. So while, and then we open up the parentheses and we use the same read line symbols. So, and in here we do exactly the same thing. So whilst it's reading in the lines, we can print out the built-in variable. And that should do it. So I'll just comment this one out. And there we go again. So we get each line from that file. Okay, so now we know how to open a file. We know how to read a file. Now we need to know how to write a file. So to understand how to do these things, we need to understand this second argument. And the second argument is the file handle mode. So what we have is less than is, let me put that in quotes, less than is read only. A greater than is create a new file if it doesn't exist, or remove all contents if it does. So let's practice that one. I'll just give you the last one straight away. So the last one would be also create if it doesn't exist, and append to end of file. So this one will just keep the contents of the file and keep adding to the end of it. Right, so let's open a file in the write mode. So that'll be greater than, and we will create a new file called info-log2 with a new file handle 2, and then what I want to do is print using that file handle with no comma there, and say new log file. Okay, so let's test that out. So down here in our directory, we can see info.log2 got created and new log file was put in there. So what happens if we run this again and put new, or write something completely different? So neddev vid. So the file stays, but it totally overwrites what's in it. Now let's change that and say append to. So, and let's put the same thing in again. So if we run this again, we should expect to see this string appended to the end of this file. Let's go back to here. Yeah, so we've got the same thing again. And lastly, this is a short script, so when the script ends, the file is closed anyway. But if you're in a more complex program that needs to write to logs, or multiple parts of a program are writing to logs separately, then you need to make sure you close that file handle so something else can read the file. And to do that is simple. You just write close, and the first argument is your file handle. So let's say file handle 2. That would be close the file handle. Oops, so we need to put that at the end, and what that'll do is just make sure we can't write to it. So to prove that, I can put this here and say, there we go, print on closed file handle, because we can't write to fh2 after we've closed it. Hello and welcome to neddev. Today's video is all about regex in Perl, specifically basic matching. Over in VS Code, we're going to create a new file called, where are we up to? We're up to file 18, regex matching. And in here, as always, we're going to use our strict pragma and our warnings. So the first thing we want to do is create a string that we can use a regex pattern to check whether we match with it. So let's say my string So we've got a string, and now we're going to open up an if statement. And what this if statement is going to do is say whether or not we have matched using our regex pattern on that string. So we're going to say my string, and this is where the regex part comes in. So we go equals and then a tilde, and what that says is we're about to supply a regex match, or certain types of regex match. So if we just have 2 forward slashes and an M, that means we're going to match, and what we're going to match on comes between the two forward slashes. So for a basic one, we could go \W, and what that does is it matches on any alphanumeric. So what we can expect to happen is that we do match, because this is full of letters. So let's run this. So Perl 18, and we say it's matched. So to prove that it's working, let's copy that down, and instead of matching on anything that's alphanumeric, let's match on digits. So that's alphanumeric, and this is digits. So this shouldn't match. There we go. So we can see that it didn't match because there are no digits in here. And if I put a digit at the end, then it will say they both matched. So the next thing to show you is accessing capture groups. So we've got this string up here, and we want to access a capture group. Let's make a new string. So my string 2 is equal to neddev loves food. That's fine. And what we can say is, yeah, let's create this again. Let's copy this down. So we're matching on any alphanumeric, but if we put this inside of a regex pattern capture group, let's say plus, or it doesn't need a plus, we can come down here and use $1. Now this capture group puts into the built-in variable $1, and we can have multiple of these. So if I show you this running, it's captured the first alphanumeric character, which is n. And if I did W plus, so that's 1 or more, then we should get, yeah, this whole word, because then there's a space, which isn't an alphanumeric. And if we want to access more than one capture group, what we would do is copy that down and say there'll be a space in there. So we can say S, and then we can put in another one. And this should print out ned again, but we've also got this second capture group in here. So to access that second capture group, we go $2. Now, unlike arrays, this doesn't start at 0 for some reason. So let's get that going, and then we get neddev. Okay, so what if we have all of these here and we don't want to access them using these built-ins? What we can do is assign all of those captures to an array. So access capture group in an array context. So what we can say is, let's make a third one. And we can say my, that's fine. And then we say my array, so matches, is equal to, then we set up our regex, so equals tilde m //, and let's just use a whole bunch of these. So we want a word, a space, a word, a space, a word, a space, and another word. So that should capture everything we have in here. Let's check to make sure that works. And okay, so no errors, nothing's being printed out, which is fine. And what we can do is come down here and say print matches in scalar context, and then 0. And that should print out ned again. There we go. And if we copy this down, say 1, 2, so the third element, and then there should be 4. Third element, so yeah. Then we get neddev loves food. and that's how to get multiple capture groups into an array and then access them. Hello and welcome to neddev. In this video we're going to take a quick look at how to implement a regex substitution in Perl. So over in VS Code I'm going to create a new file. I'm going to call this 19_regex and substitution. Now we'll open that up and add in our pragmas, so use strict and use warnings. Now to set up a basic regex, we're going to need a string to perform the regex on. So we'll say my scalar, so string is equal to once upon a regex. Now we'll close that off. To perform a regex substitution on a string, we need to call the variable, so string, and then we say equals tilde, and then say s for substitution, and put in 3 forward slashes, and then we close it off. So what these forward slashes mean are that, well, first of all, s is for substitution. Last time we just had m for match, like that. Now we have substitution, and then in between these first forward slashes, this is where we put our match, and then in between the second and third forward slashes, this is where we put what we want to go in there, what we want to substitute the match with. So here we can print out string, and we should get exactly what we put in, because we're substituting nothing with nothing. So let's try substituting once with twice and see what happens. There we go. So we can see that it's matched upon that part of the string and then substituted it with this string. So now we're going to look at some flags. So if we create another string, so let's create another string and just have many capital A's in there, and then we use a regex to substitute those A's with B's. Now you might expect this to come back as all B's, but instead, if I print out this string, you'll see that only the first one, so only that first A there, gets substituted, and that's because it's only working upon the first match that it makes. So to have it work on every match possible, we use the G tag, and that is global. So if I now rerun this, we see that all of them turn into a B. Now, as you may know, regex can get quite complicated. So if I copy this down, let's say string 3, 3, 3, and what we do is say we want to describe what this is doing. This is a very simple regex, but say we want to describe it, we can put an X in there, and what that does is allow white space. And allowing white space means that we can put some spaces in there and then put a comment. So this replaces A's with B's. Now we should see that it does exactly the same thing, but none of this is taken notice of by Perl. Hello and welcome to neddev. In this video we're going to talk about calling system commands from within a Perl script. So within our development environment we're going to create another file
which demonstrates how to call system commands. We'll call that 20 system commands. Now, opening this up, we're going to put in our pragmas, use strict, and use warnings. Now, it's super simple to call a system command from Perl. You simply type the built-in function system, open the parentheses, open some quotes, and you type out your system command. So it can be as simple as this. Now, if I save that, we can run this, Perl 20, and there we can see it's run the system command, echo hello. And if I was to do that here, we get exactly the same. The second thing to know about the built-in system command is that it returns the exit code after the command in there has been executed on the system. So in Linux, an exit code of 0 is that the program ran without error, or the command executed without error. So if we assign this here to exit code, and then we can print out that exit code. Now we should be able to see that the system executed this properly. So there we go, exit. And if we were relying on this being correctly invoked, then we could have the code do something conditionally if it didn't run, like run it again, or prompt the user that the command didn't run properly. So to prove this, I will just put some random characters in here, and you should be able to see that it doesn't run properly, so we get an exit code of 32,512.
Hello and welcome to neddev. Today we're going to be looking at the reverse function. So the basic idea is that you can flip things around, whether that be an array or a number or a scalar. So just like all the other videos, let's jump in here and create a new file, a new reference file, and call it reverse. Okay, so we've got our file open and it's got our pragmas up here. So the first things first is to create an array. And with this array, we will, I'll show you how reverse works. So let's create an array of names. So ned, dev, and Sam. There we go. And so in order to reverse this array, we can create a loop and loop over that array and print out each of the array elements in order, and then I'll show you how to loop through the array, printing out the array elements in a reversed order. So to do that, we use our for keyword and then names. And we will print out the built-in scalar. So running this should print out neddev sam. There we go, neddev sam. And as simple as adding the reverse key function before the scalar will allow you to reverse that array and print out each element in a reversed order. So what we would expect now is Sam, Dev, Ned. Let's save that and run it. There we go, so we get Sam, Dev, Ned. Moving on, we shall look at numbers and strings. So let's create a scalar for our number. Let's call that 1, 2, 3, 4, 5. Now all we need to do is create a new scalar, call that number reversed, and obviously you can call it whatever you want. Call the reverse function and pass in our number scalar.
Now let's print this out. Number reversed, new line, and we should expect 54321 to be printed. There we go, 54321, and the process is exactly the same for a string. So we come down here, change this to string, and string reversed, string, copy that down. Now let's add in an actual string, so let's put in neddev. We should expect vedden. There we go, vedden, and 54321. So it's as simple as that. You just put the reverse, you pass in your variable to the reverse function, and it spits out the reverse of whatever you passed in. Hello and welcome to neddev. Today we're going to talk about map, the function map. So over in VS Code, I'm going to create a new file called map. So map is used anytime you want to operate on a list or anytime you want to generate a list based on another one. So let's look at the anatomy of the map function. First we have the keyword map, and then we have a scope in which we would operate on the item that is iterating through in that list, and then we have the list itself. So that won't be able to run, so we'll just comment that out, but it's just there to remind us of how to construct the map function. So first things first is to map over an array that we created and just print out each element of that array. So we use the map keyword, and then we want to print the built-in array, built-in scalar from a list that we've created. So let's do a list of numbers up to 9. Close that off, and let's put in a new line character to keep it neat. Run that, Perl 22. And then we can see it's iterating through that list that we've provided from 1 to 9 and printing out each of the elements. How might we use this in the real world? So what we can do is assign the output of this map to a new array. So let's create an array called new array. We want to map some numbers into a new array. So let's create another array called my old array, and that can be an array with the numbers 1 to 5, and in here we want to take the element and add 1 to it, and we will provide the old array. And to prove that this is doing what we've said it will do, we will iterate through the array and print it out. So for my new array, I want to print and put a new line. Let's comment this out so we can see what it's doing. So our old array is 1 to 5, and our new array should be 2 to 6 because it adds on 1 each time. And then we can see 2, 3, 4, 5, 6. Let's do another quick example where we take our old array and create a new array of cubes of each of the number. So what we can do is, let's organize this a bit better. Oops. Copy this down and change the names. So instead of new array, we'll have cubes. And we'll use the old array, and we'll take the exponent to 3. So what we should expect here is a cube of each of these. So 1 will be 1, 2 will be 2, 4, 8, and then others. So here we can see that it's counted up to 6 as we've had it done up there, and then it's gone 1, 8, 27, 64, 1, 2, 5 as the cubes of each of these numbers.
Hello and welcome to neddev. Today we're going to talk about grep. Now grep is used to return elements from a list based on matching an expression. Much like if you spent any time on Linux, you'd likely have come across the same named program called grep, which is used for filtering an output. So in VS Code I've created a file called grep which has our two pragmas in it. So the first thing we're going to do is look at the structure of a grep function. So first of all, use the keyword grep, and then just like map, we open up some curly braces, and in here is when we make our evaluations. And then at the end, this is where our list goes. So we can pass in a list or we can create a list in place. So let's make this do something. So we can take our built-in variable and then we'll just pass a list of numbers. And we'll print that out. So let's run this. So Perl 23. And there we go. All the numbers from 1 to 7 that are in this list. Now we've done this basic example and you can see how it iterates through this list and prints out the built-in variable. What we'll do is create a list and make this do something a bit more useful, a bit more practical. So here I'm going to create a new variable called list of words, and in this list I will put in some random words. And we will repeat dev. Now next what I want to do is create a new list from this old list, but filtering using our grep function. So I'll create a new list called new list of words, and that will be equal to grep. Now I'll just pass in our old list of words. Sorry, I've made a mistake here. So these should both be arrays. So we'll pass in that list of words. And first of all, we'll just pass everything just to make sure that this works. So what we'll do is we will create a quick for loop. We'll loop over our new list. And we will print out each of the elements with a new line character. So what we expect to get here is neddev software dev. And there we go. We get each of them in order printed out. Now let's say we only want to put elements from this list of words into our new list of words if they meet a certain criteria. So let's say is equal to ned. Now we'll print it out, and we can see that it only ned, this first element, is equal to this conditional, so that's the only element which will be passed into the new list. So let's change this to dev and see what happens. So there we get both elements which match, dev there and dev there. So it doesn't just wait to match once and stop, it goes through the whole list, checking this conditional. Hello and welcome to neddev. In this video we're going to talk about the difference between grep and map, two built-in functions that we use in Perl. So I think the best thing to do here to understand the differences is to look at an example. So what I've got here is an example of both map and grep working on the same list. So we've got two identical lists here, 1 through 8, just the numbers, whole number integers between 1 and 8. Both of these are then passed to a new array using either the map or the grep function. So what we've got here is the built-in variable for each iteration, so 1, 2, 3 through 8 will have 1 added to it. Now this isn't our usual conditional where we'd say, is this equal to
something. This is just adding on 1 to each of those variables, each of those elements. And grep is doing exactly the same thing, except what it returns is slightly different. So if what I do is run this, it'll be slightly easier to see. So this first array that's being printed out, we have returned 2 through 9. So map is actually returning the result of this expression, whereas grep is simply checking this expression is true and then passing the original element to the new array. And as you can see there, so it's just passing the original. So although this expression evaluates to 1 plus each number, it's just passing the original number in. Let's quickly create another example just so I can show you what's happening. So I'll copy this down and just append 2 to each of these. What we should get is the same thing printed out twice, which is what we are. And instead of this expression, what I'm going to say is if each element is modulo 2 is equal to 0. So it divides by 2 with a remainder of 0, which is equivalent to saying, is this number even? So we should get an evaluation of whether each of these elements is even, and then something will be passed to the new array. So let's run this. So right here we can see, so map is passing whatever the evaluation of this expression is. So 1 modulo 2 is not equal to 0, therefore it doesn't get evaluated as 1, which would be truthy, and 2 modulo 2 is equal to 0, so we get 1. So every other number, every even number, we get a 1 passed back. Now grep, as we saw from here, will pass the original value if this expression is true. So we should expect to see 2, 4, 6 and 8 as we do. Thanks for watching, and I'll see you in the next one.